Okay, Section 3, Properties of the Moon. We know that the moon is, on average, 238,000 miles away. That's an average because, of course, it's an elliptical orbit. It's not perfectly circular, so it changes. That's why some full moons are larger than others. And the largest one of the year gets called a supermoon. Seems to be kind of a new term they came up with. The way we know this, by the way, legend has it that the Apollo astronauts left mirrors on the moon, and that's actually true. They actually did. They left reflectors, and we can shine a laser, bounce it off the moon, and based on the time it takes to get back, we know exactly how far away the moon is. Some other basic properties. The moon is about 1/4 the Earth's diameter, so it's really a big moon compared to the size of a planet. However, it's less than 1/80th the mass of the Earth. Now, what does that tell you? It tells you that it's not very dense. The moon is kind of the odd man out in the inner solar system, and we're going to have to explain why later in the chapter, because that is kind of odd. This lady struggled with this apparently on Who Wants to Be a Millionaire, which of the following is the largest. Yeah, the moon is actually larger than an elephant, believe it or not. All right. Some physical properties. Here you have the moon versus Mercury. You see it's almost as big as Mercury, but far less dense. Look at that 3,300 there. That's really what stands out about the moon. Okay, in class I demonstrated this, that the moon is tidally locked with the Earth. Now, we do say technically that the moon spins on its axis. It just happens to spin at the same exact rate that it's going around the Earth. So you notice the rate of spin on its axis is exactly the same as the time it takes to orbit the Earth. That's a 1-to-1 synchronous orbit, or, as I mentioned before, we say that it's tidally locked. But the net result, whatever you want to call it, the net result is the same face of the moon is always towards the Earth. It's always the same face towards the Earth. Every day of your life, whether it's a crescent moon or a full moon, anything in between, you're seeing that same face of the moon, which is kind of interesting. It was tidally locked a long time ago. And that's basically because the Earth is so dominant over it, gravitationally speaking. Now, to have a magnetic field, there are two things that are required, essentially. You want a fast spin. Well, we just said the moon takes an entire month to spin one time, so that's a slow spin, and you need to have a molten iron core. Well, the moon apparently cooled off a long time ago, and it doesn't have a molten core. So it doesn't have, for example, active volcanoes, and it doesn't have a magnetic field. A compass would not work on the moon. No magnetic field for the moon. And that's not surprising. Small places, small moons, and small planets typically don't have magnetic fields. Mercury was kind of a surprising one, and even its field is weak. Okay, well, that's actually it. We're going to keep it short and sweet here for Section 3. Thanks for listening.